Hello, I'm Xavier Sneed, and I am a computer engineering major with a math minor.
Hello, my name is Devon Williams. I am an electrical engineer with a minor in music technology.
Darren Buck, major in electrical engineering, minor in computer science.
Felipe Martinez, major in electrical engineering.
What is the name of y'all's project?
The Acoustic Material Manipulator, or the AMM for short. The function of the project is to use acoustic vibrational patterns to levitate and move an object in three-dimensional space without the need to touch it. So it's hands-free, completely contaminant-free. What we would like to do with it would be to revolutionize the field of pick-and-place machines that populate PCB boards with the IC components instead of using a one-armed robotic process to pick up and place one at a time. This has the potential to pick up multiple pieces at once, move them independently, and as soon as it gets to the next matrix area, it can have 10 more up at the time. So it's an endless wave. So it consists of an array of 16 by 16 transducers that each output its own specific sinusoidal wave at 40 kilohertz at about 9-volt peak to peak. So it works as far as each individual local point is put into a matrix of vectors that encapsulate the particle and make it float. After that, in the movement of it, it just kind of passes it on to the transducers that are coming next.
What are the next steps that we're going to work on for this project?
The next steps are going to be shrinking the array as far as getting more precision out of the bubble itself. It would limit the mass that you could pick up, but at the same time, giving more precision would be perfect, especially for smaller IC components. So we have a 4x4 array we're putting together and also a 10x10 array. And we're also experimenting with larger transducers. These are a 10 millimeter. The 4x4 we're building is a 16 millimeter transducer.
And throughout working on this project, have y'all encountered any challenges? And if so, how did y'all work to overcome them?
We initially wanted to completely reverse engineer this, but it proved too difficult especially just as far as time management went. There was not enough time and not enough knowledge behind the subject as far as the physics goes to completely rebuild their software. So we're using a third-party software. That was a very big challenge. Most of our challenges came in the beginning with trying to do it that way, trying to make our own sinusoidal waves, trying to get them to migrate to the next transducers, make the matrix, everything like that. All the algorithms were very difficult. Trying to find an FPGA that would be able to handle the instructions or processes necessary in a short amount of time.
Of this, we have gone through the FPGAs that we have to do, because I think we blew like, what, 3?
Those 3 FPGAs.
Yeah, we blew like 3 FPGAs.
Just some of the challenges and everything we targeted were kind of dealt as a team, kind of taught us how to work as a team within each other and as a group, how to communicate, and this is definitely a good team building experience for senior design too. And this was definitely a challenging project, and the thing that's unique about this project is that there's barely any information as far as how this works, how the principle of levitation works. So it was good to challenge ourselves into something that hasn't been researched on that much. So it was definitely a good learning experience for that too.
While other people are going towards this idea, they're not doing it like we are. We're trying to hopefully be the first people to market this, to help the pick and place machine. That way we can replace the robotic arm.
How is the Makerspace able to impact y'all?
Locker in somewhere for all the team to meet up every once in a while to go over things, to go over problems, to go over progress, store things, make it easily accessible, because some of us are on the west side, some of us on the north side, some of us are on the east side, some are here on campus. So this was the local meetup spot.
And we also can thank the engineering department allowing us to borrow the power supply, and it really did help us try to hopefully develop a product that could change the world.
We are the Levitators, and you're watching Makerspace Monday.